Hello, Oliver Fernando. How are you? ¿Cómo estás, Alo? Ok. Oh, God. Hello, hello. Let's wait a little bit for the others to get inside this video calling and we will start in a moment. Meanwhile, okay, 15 people. Let's wait a little bit more. Yes, Juan Pablo, tell me. Okay, ya les digo, tranquilos. Today we are going to talk about a topic that is a little bit more complex than the others that we have seen this term so far. So I prefer that you pay attention to me today, and you can have the information in Padlet. This is later. So for today, I don't want you. I want you to, if you can copy the information, that's perfect. But if not, I prefer that you, yes, copy later. I prefer that you pay attention because this is not as simple as the previous topics. So we need to do it really slowly and step by step because we have to take into account a lot of different concepts. So it's not as easy as the others. Okay, let's see. Beltran, she's here. Bernal, Lucas, no, Beltrán, dizque, ya. Huitrago, Castro, Castro yo lo vi. Cuellar está, Guijo está, María Valentina, no la veo. Mariana está, Miguel, no lo veo. Sara, ahí está. Violeta está, Navarro. Salo, no se te olvide crear tu propio correo, ¿vale? Ana María y Federico, hello. Pardo. Ah, Castro sí está. Sí, sí está. Pardo es el que no está todavía, no demora. Quiñones, no lo veo. Mafe, ahí está. Sofi. Chicos, me dicen que. ¿Quién es Caño? Ah, pequeña diferencia, como en varias letras, ¿no? Gracias. ¿El es solo en mis clases o también falta las demás? ¿Saben por qué? ¿Alguien ha hablado con él? Majo no está, no la veo. Rojas, Sebastián Rojas, no está. Ok, si pueden comuníquense con él, yo voy a hablar con la profe Constanza a ver si ella sabe, pues, para qué se debe eso, y si no, pues yo envío un correo personalmente a ellos. Sara Santos está, no está, seguro está, y Emma está. Ok, so just a little bit more. There is a lot of people that is missing, and I want to have the greatest amount of people for this explanation. As I have told you today, this topic is a little bit more complex than the others, and it's new. This one is new. I think that we should start right now. There's a lot of people missing, but we need we need to go. So did anybody had any problem with the Alex activity, or everything was correct? As you see, um, oh, in progress, in progress, in progress. You can tell those people, please, that please come to the class because this activity closes on Friday. So you don't have to worry about that. Um, and you have 5 attempts because this one is graded. So this would not be infinite attempts, only 5. But I think that's enough, and most of you got a 10, right? So please, people, save the activity for later. If you are here and you can listen to me, tell your partners to come here. That don't worry, that save the activity. And I really need you to pay attention. You can finish that activity, this Alex activity, in other time because it closes other day. It closes on Friday. Uh-huh. Yes, now it's oh, Quiñones, Prada, Federico. Okay, bueno, anyway, let's start because this is really um, dense, to say it one way. Okay, kids. So today we are going to talk about geometry, um, and we are going to talk about the homotecy, which is a polygon transformation, as you can see here in the next slide. Homothecies are polygon transformations, but they are not isometries. So who's the last person? Who's the last person that wrote? Ah, okay, Anita y Federico. So please, one of you, I want you to talk, please, because you're going to answer one question for me. No problem. Hello, Ana and Federico. What's up? Please talk. Open your microphone because I want you to answer a question. Hello? Please open your microphone. How are you, Ana and Federico? Everything all right?
Okay.
Okay, so you are going to answer something to me. Do you remember what are isometries? We talked about of them a lot last geometry class. Do you remember the meaning of isometry?
Me suena la palabra, pero no.
Okay, there and okay, Federico doesn't remember. And Dana?
No.
No? Okay, Juan Pablo, can you help me please? Thank you, Ana and Fede.
Isometries are that are modifications to a polygon, but
Uh-huh.
it does not uh, um, alterar. I don't know how to say that in English.
Modify or
Modify,
alter.
modify the size and the structure of the polygon.
Exactly. So isometries preserve, thank you, Juan Pablo, shape and size. Yes, that remains the same in the original and the result. Esto es una flecha. And the result. Yes, it doesn't matter the position, but homotheses are not isometries because the size of the image is going to be different than the original. But we will see them, we will see that, sorry, step by step. Because before understanding that, we need to have really clear in our minds 2 concepts. And one of those you already know it, which is the concept of congruence. We can say that the 2 figures are congruent when their shape, look, shape and size are completely equal. So here you can see okay, and you use this symbol to represent that two things are congruent, like here. So in this example, you see two triangles, the triangle ABC and the triangle A prime, B prime, and C prime. As you can see, the triangles are really look alike, se parecen mucho. And that is because they are congruent. So congruent means exactly equal. Because, for example, this side is exactly the same length than this one with this, the other with others, and also the angles. Look, this angle, the angle BAC, is exactly the same amplitude than the angle B prime, A prime, C prime. So everything, all of the elements of the two figures are equal when they are congruent. Yes? So remember, congruence is simple. They mean exactly equal. Is it clear or does anybody have any question about it?
Clear.
Clear? Thank you. If you have any question about this concept, please open your microphone and talk or write in the chat because we need to move forward to the other concept, which is not that simple as this one. So, okay, I think no questions. Now, we are going to talk about the concept of similarity, and we represent similarity with this symbol. Yes, just for your information. Look, the definition. In order to say that the two figures are similar, their shape, la forma, has to be equal, regardless any difference in their size. So, regardless means sin importar any difference in their size. So the shape, la forma, has to be equal, but the size, it doesn't matter. It can be bigger or it can be smaller, but if the shape is equal, the figures are similar. And in Spanish, the proper term is semejante. Yes? In English, we talk about similarity. In Spanish, we talk about semejanza. No vayan a decir en español que son similares, porque de pronto hablan con alguien que no sepa inglés y no les entiende. Se dice son semejantes. ¿Listo? Okay, and I want to ask, okay, Mariana Lopez. Hello, Mariana. How are you?
Good teacher.
Okay, Mariana. Okay, you are going to answer the following question to me. Look at these two figures. Do you see them, right?
Yes.
Okay, do you think these figures are similar or not? Just by looking at them.
Mm, no.
Why?
O sea, vamos. Ah, no, yes.
Why?
Because the blue,
Uh-huh. The
no,
blue, yes? No? Yes
yes,
or no?
yes.
Uh-huh.
La figura
Uh-huh, yes.
is volteado, o sea, volteada.
It's flipped. It's flipped by Mariana. We saw that word last class. Okay, anyway, don't worry about that. It's flip, está volteada, yes?
Ajá.
But they are similar or not?
Eh, mm, mm, so.
So what you don't know for sure, but
Yes.
what do you think is more probable that they are similar or not?
Yes.
Okay, so actually they are. So and let me have this clear. This is flip, está volteada, ¿vale? So let's look at the next slide because in the next slide I flip that figure. So the figures are in the same orientation. Look, Mariana, can you please close your microphone? Thank you. So in order to understand easily, let's assume that these triangles are similar. So vamos a asumir que sí lo son. Y sí lo son, pero pues todavía no se los he demostrado. So let's assume that you can see some colors and they represent corresponding sides. Okay, be careful with the concept of something corresponding. We are going to see this really in depth a little bit in some moments in GeoGebra. So they represent corresponding sides, lados correspondientes. If they were in the same position, the colors would be in the same place. ¿Cómo así? Que si estuvieran en la misma posición, los colores estarían al mismo lado. Look what happened. I flipped the figure to have them in the same orientation, and here you can see that the colors are in the same place. So this side, this one, is the corresponding side to this one because they are in the same position of the two figures. The blue one is corresponding to this one because they occupy the same position in the two figures. And this pink is corresponding to this one because that they occupy the same position. We need to understand the concept of corresponding elements in order to prove that the figures are similar. Other way, we are going to do wrong stuff. So remember, corresponding elements occupy the same position in the two different figures. Is it clear or is it confusing? Okay, so I think it's clear. Anyway, okay, yes, I understand because this
O sea, profe,
explanation,
lo que nos estás queriendo decir es que esas son similar porque una es más grande que otra.
more or less, but more things play a role in this because we cannot say that, for example, mira, do you think that these are similar or not?
Yes.
Well, actually, no, because the shape is close, but it's not exactly the same.
Ah,
And we exactly, but we need to understand the concept of corresponding things to be able to prove it, because now they are similar. Si ves que cambió un poquito y ahora sí son similares,
o sea, tiene que ser
semejantes.
exactamente de la misma forma, pero no importa el tamaño y la orientación.
Exactly, yes, because this can be in any other orientation. I just
Ujú,
drew them in the same orientation to facilitate the things.
ujú.
Because look, the shape is, pero es que agrando los dos. The shape is the same. Look, you can see, no, espérate, casi, casi, close, close, close. Ay, Jesucristo. Yes. The figures are similar. Ay, Dios. Es que están súper descuadradas. Yeah, now. So let's go back to the concept of corresponding sides. Now that that we have the figures in the same orientation, you can see that this side is in the same position than this one. Mhm. That this side is in the same position than this one, and the same with the points. The angles, the angles have also corresponding angles in the other figure. So for example, this angle is corresponding to this other angle. Yes? Not to this, not to this, no, to this one specifically, right? Why do we need to understand the corresponding things? Let's look at the slides. Hmm? Angles of similar, yes. Here we have the main explanation of similarity, the easiest one that you are going to find. The corresponding angles of similar figures are the same. So look, here we have two similar figures. They have different sizes, but we can know that the shape is the same because all of the corresponding angles are the same. Let me draw. This angle, este, measures exactly the same than this one. This angle measures exactly the same than this one, and this other angle measures exactly the same than this one. Yes, when all of the angles of the figures of the figures um, measure the same, the corresponding angles, we can say that the figures are similar. So let's confirm that. Let's confirm that with the triangles that we have here. I am going to draw the angles that they have. So here, look the measure of this angle. This angle measures 75.96 angles, degrees, grados. So let's measure this one, 63.43, and let's measure this one, 40.6. Now, this measure should be the same than here. Let's confirm. 63.43, yes. 40.6, you see, here, and this one should be 75.96. So all of the angles, of the corresponding angles, measure the same. So that is how we can know that the figures are similar. When all of the angles of one figure measure the same than all of the angles of the other, they are similar because their shape is going to be equal. It doesn't matter the size. Why, kids? Let me move this one outside. I don't want to see it right now. Look, when I have this triangle alone and I make zoom, you can see that the sides increase or decrease. The sides are turning bigger, the sides are turning smaller. But what happens with the angles? They are making bigger or slower, or they don't change. The angles never change. It doesn't matter if I change the size. But what happens if I change the shape? All of the angles modify. All of the angles change their measures. So that means that the shape changed because the angles are always constant when the shape doesn't change. So, ahora se me olvidó cuál era cuál. 75, I think it's here. Aquí. So they are similar. Look, this coincides, this coincides, this coincides, and this one coincides. The shapes are the same. Es como una copia más chiquitica. Is it clear or do you have any question about it? Clear, thank you. Is clear, that's great, that's great. Any question? If you have questions, please write or talk right now. Marisol has it clear. Really good, Marisol. Okay. So let me open Class Dojo because I am going to ask some things before continuing with the concept of homothecy. Actually, I need to talk a little bit more about similarity because there is more to that. But for now, you can understand that similarity is when the figures have equal angles. That's it. That's the easiest way to understand it. Gijo, hello Gijo, how are you? Please talk.
I know. Hello, teacher.
Hello Juanjo, how are you? Okay, Gijo, you are going to answer a simple question. In your words, please tell me what is the congruence of two figures? What happens when two figures are congruent?
are equals
Are equal? Equal in what?
in segundos está claro, es lo que se me acaba de olvidar.
There are many, principally two things, mainly two things. Equals in.
I know this figure from
Okay, say it in
this word,
Spanish.
but
Say it in Spanish. Don't worry.
lados
Lados, more or less. And what other thing?
and
Mainly two things. Más o menos dos cosas. Los lados sí, pero podrías decir una cosa más general. Vamos, hijo, tú puedes.
así no lo sé.
Or do you surrender? Do you want me to help you? Or other person to help you?
No, el ancho.
El ancho y los lados. More or
Teacher,
less. Thank you,
teacher,
hijo. Yes,
teacher,
Mariana.
de los ángulos,
Yes, the angles. Mhm. And what else?
no sé,
Okay,
los,
yes, the angles and the sides. Yes, but more general, that refers to the shape and the sides and the size, sorry. Eso se refiere, claro, los ángulos, perdón, hablo en español. Los ángulos se refieren a la forma, porque es lo que no cambia cuando no cambia la forma, y los lados se refieren a la longitud de esos lados, que es el tamaño, ¿cierto? Shape and size, forma y tamaño. Yes, when they are congruent, okay? But I am going to ask another person. Thank you, Guijo and Mariana. Maria Valentina, how are you? Hello, Maria Valentina. Valentina, is she there? Okay, F. Another person. Miguel. Hello, Lucho. How are you? Miguel. Miguel. Ah, hello. Problems with your microphone? Or can you use your microphone, Miguel? Okay, so Miguel, please tell me the difference. No, I mean, w- um, in your words, when can we say that two figures are similar? Okay, don't worry, Miguel. This class is being recorded, so and please pay attention to Lucas, who is going to explain when can we say that two figures are similar. Don't worry, Miguel. Hello, Lucas. Okay, no problem, Lucas, but please explain that through the chat. When can we say that two figures are similar? When the shape is equal. And what happens with the size? It doesn't matter or it matters? It doesn't matter. Perfect. And what elements of the figure can you use to determine if the shape is equal? What can you measure to see if the shape is the same, regardless the size. Don't worry, Angela. Thank you, Lucas. That's great. It's the angles. Angela, don't worry. This is being recorded. I know that some of you have problems with the connection and with the audio. No problem. When you have problems, please anyway tell me to see if it's a problem of everyone. If it's a problem of everyone, it's because of my connection. But I think no, right? Yes. So, Lucas, thank you. When two figures have the same corresponding angles, like here, look, this has the same angle, this one, this one, this one, this one. It doesn't matter if one is smaller than the other. They are similar, son semejantes. En español se dice semejantes, recuerden. ¿Vale? Mm. What happens if I rotate or I reflect simetría axial, simetría central, inversión, rotación? Let's reflect this. Ay, ¿qué hice? Let's reflect this. Objeto a reflejar, luego eje de simetría. I have to create an axis. Perdón, creo el eje de simetría. Look. Here, I created a reflection of this figure. What do you think? This big is similar to this reflection? Answer in the chat if yes or not. Tranquilos, Ana y Fede, no se preocupen, esto está siendo grabado, así que cualquier cosa, si tienen dificultades, pueden consultar el video. So everyone, please answer. Do you think that this is similar to this reflection? Yes or no? Salo says yes. Who else says yes? Who else says no? Gabo says yes. No one else? Okay, so I am going to ask Gabriel. Hello, Gabo. How are you? Hello.
Hello.
Okay, Gabo, why do you think that they are actually similar?
Because the figure is rotate.
Uh-huh.
No sé, y por eso yo.
Okay, so what should happen? What should we measure from this one to confirm that this is similar to the big one or not?
Mm,
Agavo, we should measure. Okay, what did we measure with the originals? The big and the small originals. They have always the same angles. We should measure also the angles of this. And little spoiler, the answer is yes, they are similar.
sí.
Because this is congruent to the other one. This is exactly the same than the other one, just flipped. But the orientation doesn't matter. Look. They have the same measures of the angles. Obviously, the orientation is the same. So this one with this one with this one, estos dos iguales, but we need to reorientate to confirm. But yes, they measure the same, so they are the same. And these two, it doesn't matter the orientation. What matters is the measure. So yes, they are similar. It doesn't matter if it's flipped, if it's rotated, if it's translated. If the angles measure the same, they are similar. So I think that right now it's pretty clear when the two figures are similar or not. What matters is the angles. Yes, but there are other characteristics of similarity that exist and that we can also use to confirm. But the easiest one, kids, is the angles. So right now, I am going to talk about another one. Why? Because you can also use the measure of the sides in order to confirm the similarity of the figures. But you may say, teacher, look, they don't measure the same. This measure 4 to 4, and this one 2 to 1. If the measures are not the same, how can we use those numbers to confirm the similarity?
Yeah, but they are the halves.
Exactly. In this case, not always, because other relationships may be of decimals and fractions, and it's going to be a little complicated. But yes, it's basically that idea. If this measure is the double of this one, of the corresponding side, all of the measures in the first one should be the double of their corresponding. Look, 4 is the double of 2, 4 is the double of 2, 2 is the double of 1. But what happens if we have difficult measures like decimals, like fractions? So let me use this example. Let's measure these sides. Espérame, let me put it with the original so we can see easier the corresponding sides. So I am going to put the measure. The measure is, es que yo también la hice con el doble. Es lo mismo. It's the same. Na, na, na. Valor. ¿Qué hice? Ah, es que me di fue la figura, no el segmento. Configuración. Valor. You see, it's the double. It's the double. And everything is going to be the double. But let me find another example, which is... ¿Cómo lo hago? Okay. Sorry about this. I am going to look for Google Images. Let me see if here we can find images. Es que todos los ejemplos son el doble. Yes, you see, and the idea is that, okay, in this one, this is the triple of the corresponding side. This should be the triple, so this should be 12, and this should be the triple of 5, so 15. Let's do it in GeoGebra. Let me do it. 3, 4, and this one is 5. And this one should be 3, 4, 5. These two figures are similar. Let's look for the measures. Configuración. Ay, Dios mío, ¿qué estoy haciendo? 6, and this one. 15. Okay, pasó algo muy interesante. Something really interesting happened. You know that this grid expands and contracts if I make sum or not. So what I saw as 3, it were actually 6. Miren, es 6. But what I saw as a measure, it's going to be 15. And this is perfect because it shows what I wanted to explain to you, which is how can you know it if it's not as simple as the double or as the triple? Well, you have to make the division of the corresponding measures. 15 divided by 6. Let's do it here. 15 divided by 6. Or you can say it 15 over 6. Ahorita la hacemos. Let's look at the others. Ten and 25. So 25 and 10. Porque estamos cogiendo la grande primero. Eso es importantísimo. 25. Ay, Dios. Ay, no, que no. Es que está fallando esta cosita. Horrible. ¿Qué hice? Jesús. Aquí está. 25 and 10. Permítanme, yo hago esto. ¿Es? Miren, estamos cogiendo 15 with the corresponding 6. 15 divided by 6. And 25, este grandote, este, with 10. Ese 24 es el área, chicos. 25 with 10. If we make this division, or if we simplify those fractions, which this we can divide it by 3 and we can divide it by 3, it's going to be 5 halves. Let's simplify this one. We can divide it by 5 and we can divide it by 5. 5 halves. Miren, la fracción termina siendo la misma. Y si lo hacemos con división, va a dar el mismo resultado. Lo podemos hacer en calculadora. Let me open the calculator. Eh, 15 divided by 6. 15 divided by 6 is 2,5. Now, 25 divided by 10. Ahora, 0. 25 divided by 10. 2,5. ¿Sí ven que dan lo mismo? And that should happen always when two figures are similar. So if we do the same with this one and with this one, the result is definitely going to be exactly the same. Yes? But don't worry, because we are going to continue with this topic in other class. Here in Padlet, I put today's day 3, right? No, day 2. Day 3, we don't have class. And the next class, yes, perfect. Next class, we are going to continue with this topic. I had planned for you an activity that you have to use scissors to create polygons and then compare something. But before that, I prefer to keep explaining this topic because it's a little bit more complex than the others. So before we go, we have 2 minutes left. Do you have any questions that I can solve right now? Remember, we are going to continue with this topic, no problem. No questions, Sarah? That's great. Salo doesn't have any other question. Thank you. Mafe doesn't have questions. Gabo doesn't. Lucas doesn't. If anybody has question, please talk right now or write in the chat. And if you don't have any question, kids, thank you very much. And please don't be late to your last class of today, please. Bye-bye, kids. Thank you very much. Did you like this topic? Is it a little bit difficult or it's good enough? Bye, bye everyone. Bye Sara, bye Salo, bye Gabo, bye Juan Pablo, bye Lucas. Castro ya le dije. Bye Castro. Bye Mafe. Okay, thank you very much, kids. I am going to start kicking you out of this. No, before I am going to record the chat. Un poquito difícil. Don't worry, Fede and Ana. Tomorrow we are going to keep talking about this and making everything really clear. Okay, thank you. I am going to kick you out, Miguel. And, uy, tengo 3. Impresionante. Bueno, me voy.